Okay.
Yeah.
Yes. In Claude and any even Open Claw, it is those markdown files which are soul.md or dream.md and all those stuff.
Mm.
Those are actually the skills that you are giving to the agent, and sometimes it is also compaction of a directory where you have actually written the code, and skill can actually go and execute that code.
Yeah.
So but those are all internal stuff that you are actually attaching it to the agent to make it intelligent.
Mm.
The tools, how they say that there are tools, are those external tools or maybe internal tools. Sometimes when there are external tools, they are connected through MCP.
Yeah.
Okay. Yeah, I agree with that. I didn't use the cloud, but I gone through some tutorial, some one video of 1 hour, 2 hour related to the skill that somebody was showing. That
Okay.
okay, that how
Mhm.
the skill is. Now I can remember. So here the skill we, as per this book, we try to limit with the tool only, but you are correct.
Okay.
So tool, in other word, we can say skill. Yeah, now I can exchange little bit. Tool is the starting, but the more broader part of the say superset of the tools is skill. Like other than tool, there's the something else as well. So skill
Yes.
kind of thing that can perform your one task end to end.
Yes. Yes.
Okay, some
Agree.
kind of
Agree.
task. So tool cannot do your single task, but group of the tools, I will say. Okay, one tool, like group of the tool, or and it can fulfill one purpose or one activity or one task. It can do a project task or anything. It can do anything. They may be calling that a skill. So here
Yes.
also,
Yes.
it is similar to that only, but not just like the project. Say one project inside there, another project, some their broader project. So I think that's where, that is how it looks to me. Okay. So yeah, somebody raise
Okay.
the hand.
Manoj.
Manoj.
Yeah, Mohan. So I also wanted to actually share how I understand it, right?
Mm.
Difference between skill and tool. So if we take, let's say, an example of this travel booking agent, right?
Mm-hmm.
So it will have access to these different tools or MCP servers, let's say to book airlines ticket, to book hotel, to book rental car.
Mm-hmm.
And like those tool definition will tell like how to call a particular API, what input to pass, what to expect, right? So that's a tool definition. It will just tell you how to make, how to invoke that tool.
Mhm.
But the skill is like you can say business logic or knowledge that's beyond just one tool. So like for example, you can say that oh uh, airlines bookings are not refundable, so first actually book the rental car and the hotel, and then after that, once you secure that, then only book the airline ticket. Or like company might have a rule saying that if the flight like if the distance is, let's say, more than 8 hours, then book business class. So
Mhm.
all these things, they cannot go in tool definition, they can be coded or captured in the skills.
Yeah, makes sense.
Yeah, 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 makes sense. Agree,
No,
agree.
because the problem is if you are working on cloud or something, skills. Now here I mean, in the book is saying skill is nothing but tool. That puts some confusion. What exactly? Yeah, makes sense.
Yeah, right. And we need to understand that one, because this landscape is evolving so quickly, right? New
Yeah,
tool, new framework, everything, every day, every week, new things is coming.
yeah,
So still things are not clear. They're wild west everywhere. Like, that things are also evolving, and so they are coming. So you know that's where the confusion is as well. Somebody referring something. I think in the coming days, in the future, the things will get more clear, right? Okay, either we are in the process of that. Okay, so yeah, let's go back to the here. So then, once you build a skill, orchestration is what turn them into the real work. Okay, and makes sense. Once you have you build the skill, then you will orchestrate them. Okay, which skill to call and how. Then they will do the real work. What turns into the real work. Think of orchestration as agents control panel. Okay, so when agent, so when the think of orchestration as agent control panel. Like, so when, so this orchestration, like control panel, how different skill are there, it will orchestrate. Okay, so now moving to the next. Why orchestration matters? So simple task can be handled with one skill, one decision, and one execution. And the real task require multiple skills, dependencies between the skills, decision based upon the intermediate results, adaptation when assumption fails. Yeah, it makes sense. As the Manu sir was saying, like, you complete airline book, the travel booking agent, it will have the different skill, like, hotel booking, airline booking, car booking, check the weather, right, check the price and everything. Okay, so multiple skills are there, they will work together, they may fail it. Okay, that is the real task, book a travel ticket. Okay, travel ticket. So all these filters on all this only, like multiple skill, dependencies, decision, and all this. Okay, and now coming to orchestration handles skill orchestration. What do you send? Skill selection. You select the skill, then skill execution, and skill composition. So composition topology is like, how the which different skill you will take it together and then perform the task. And planning strategy. These are the four things orchestration handle: selection, execution, composition, and planning strategy. Okay, now the idea why orchestration matter. Now second, skill selection strategy. So as per the book, skill selection is the foundation of orchestration. That is the first thing that it does. And what how it select the skill? So type of the skill, like generative skill selection. LLM sees all skill description, it choose the best skill directly. So generative skill selection, like, based upon just it is reading the description and selecting the best skill. Even earlier the framework that whatever we were doing, or either the agno or the this one, any the lang chain framework, then when we building the agent, so LLM select that tool based upon the doc string that in a Python function, that whatever we wrote it based upon that script detail only, it's selected. The same way the agent, so skill is the broader part of it, that's what it will does it. Okay, and so what are the pros for it? Is very simple: no embedding or the databases, good for the small skill set. Small skill set. Cons for this one: extra LLM call, higher latency, don't scale well. So these are the negative part of it. Use when early prototype or very small, for very small system. If you are very small system, then you should use the generative skill selection. Okay, now coming to the second, semantic skill selection. It is saying that is the most common. Each skill is embedded ahead of time. User input is embedded at runtime. Vector search find the best matches. LLM fill parameter and execute. Okay, so this was the just reading and doing it. This is a more kind of the semantic search, the way how this rag and other work, like, you have the string, maybe the detail, you will convert that into the embedding vector, embed vectors, and do the search so that it can uh, find the best. Okay, based upon the input. So all these is embedding selection, semantic selection. What are the pros for it? Faster than generative selection, scale well, and has a high accuracy. Cons of it require embedding plus vector storage. That's the cons for it. Like, you just need to have a vector storage. All these things you need to do. Okay, these two things, because the semantic selection you need to embedding, you need the vector storage. Recommended default for production system. This is the default recommended and the default for the production system. Third skill selection is hierarchical skill selection. Skill are grouped, like grouped computational automation, like group of the skill, they are grouped together. Not a group of the skill are grouped based on certain, so the example, like, computational automation or maybe something else. Okay, first select a group. First is to select the group, then select a skill inside that group. That is hierarchical selection. Pros: higher accuracy with many similar skill. Higher accuracy with many similar skills. So when the skill are grouped, then it may have the many skill nearby in that group. All type of the skills are in that group only. So higher accuracy with the many skills. So there are the many skills are there, then chances are there it will select the best skill. Cons: more complexity, higher latency, and more maintenance. Because so it is the advantage of it, because you are grouping together and then selecting best out of one of the skill from that group. But these are the cons: more complexity, higher latency, and more maintenance. Uses when you have many overlapping skills. So if there are the many overlapping skills are there, then you need to go for hierarchical skill selection. Okay. And fourth, D part is machine learn skill selection. Train a classifier on task, then skill and pair. Train a classifier on pairs. That is a machine learn skill. What is the pros for it? Lower latency, cheapest as scale. What is the cons for a new model to maintain? Need training data. Because so whatever the skill it want to select, then you need to train the model, and so all these things you need to do extra if you want to achieve. When to use: scale is large and latency is critical. When you want to scale it at larger scale and you don't want very low latency, okay, then you need to choose this skill. Yes sir.
Yeah, so the question is why latency is pictured right now? We are selecting the skill, right? We are not executing the skill. So is it because we are putting that into vector database and that latency it is talking about here?
Yeah, correct. Because
Oh,
you will that is not the directly, because first you will whatever the input you will, that will convert to the embedding. Okay.
yeah, yeah, yeah,
So
that
first,
makes sense.
first your skill that converted to the embedding,
Yeah,
then
that
embedding will
latency.
go to the database. When you will give the input, then again it will go to the embedding.
Yeah,
Okay.
yeah, makes sense
Then the
completely.
comparison will happens, and then it will give you. So because of this, because embedding will come into the picture, then the latency will increase
Yeah. So
because of
one more thing I want to mention here. Let's say we are using LangChain or some framework.
Mm.
Uh, the skill selections, we are not doing anything extra there with my understanding, whatever I have seen. So you are
uh,
saying by default it is semantic skill, right? That is what.
So this is, I think they're not the technology, but this is more kind of, I say, the the design pattern thing. I need to see the example. I cannot comment on that. Okay, if somebody have read it or see the example, then they can. I generated some lang code for it. Okay,
Mhm, mhm.
but I used to review it. Okay, I can understand it, but I even the same question for myself as well. Like these are the skill selection, because the lang, but the lang chain documentation I gone through, I didn't
Mhm.
see such thing. Okay, so
Yeah.
this
So
book, good. This book, practically don't have many, because this book is still is raw, is not completely edited yet, right? Okay, so it has some example, but not many code example. It has, it is have more kind of the concept, right? Thought process, like when you are building the system. Okay,
mm,
so it will, I'll say, you will develop the skill to think when you are going to design a system. And at this point of time, I will say, because we are, everybody is learning. So okay, like understanding these theoretical concepts, so that we can relate with our problem, that is more needed, I believe. Because if you go to the documentation of any framework, either langchain and agno or any other, documentation of those is not that large. Seriously, if
yeah.
even one
So
or
no,
two days
I
you
am
read
not
it, you can go
asking.
through.
Yeah, I'm not asking a question here. I'm just mentioning that I have not seen that skill selection specifically you can provide. Maybe by default internally it is taking that, the context or something. You said number two or something. That one is default, right? But one more thing I want to mention here, what
Mhm.
people are doing is they are storing intent and
Mhm.
they are storing, let's say, corresponding tool name. So let's say you are saying, as Mono's given the example that okay, let's say we are choosing the given the booking ID, we are choosing a to call a hotel or to call an airlines. So
Mm-hmm.
there might be 10 or 20 intents they are storing, and this is
Mm-hmm.
the full ID they are storing in the vector database. So whenever user is given an input, I mean, whether you, when user, I mean, we get the input, we are mapping with the intent. Is it closer to this intent, this intent, and then what will be the corresponding tool or skill, whatever is the nomenclature here we are using. So that is why, that is what also we are doing. That is one of the information along in this one I thought to share.
Oh yeah,
Next.
yeah, yeah, yeah. Really, the thought very good. Even I am having the similar thought. Okay, okay.
Yeah,
But
yeah.
let's see. Let's finish the complete summary of this
Sure,
book.
sure.
Okay, and then we'll deep dive. We see the code example as well in the remaining time. Okay, and we'll try to grab as much as knowledge from this book. Okay, I just going through that book, but it was became very lengthy. Okay, so I thought of let's get the summary, then go slowly deep dive and see some code example. Okay, so hierarchical selection, machine learned selection. Now theme skill execution. Okay, so this one the skill selection. After that the point was there. Okay, so coming to okay, first matters. Okay, what matters and skill selection, type of the skill selection, and the third part skill execution. That how in which or how skill execution related concept. Once a skill is selected, okay, one parameterization they call LLM fill function argument like agent state plus context injected input validated type check. Okay, okay, so when it will try to when the execution will happen, these are the things will take place. Parameterization, so LLM fill the function argument and the agent state plus context injected and input validated type checked. So they're just trying to put more in the theory, but that we can understand or we knew like whenever the LLM only everything do does, right? It identify the tool, right? And based upon the description it grab the parameter and fill it. So that's what it is saying, parameterization will happen. So this is one of the during execution of the skill this happens. Execution local function or external API they we call and handle retry timeout for the failure. That makes sense. Once it's selected the parameter, so it is selected the skill, then prepare the parameter, then it will execute it, right? Either it call the local function or external API, and if there is something wrong, then it will try retry timeout or failure, all the those exception and everything it will handle. Yeah, it makes sense. Parameterization then execution. Execution quality determines, right, reliability, user trust, and system robustness. Execution quality determines reliability user input and this concept. Okay, and now next come skill topology, how skill combines. Okay, so now the particular skill selected executed, and on top of that to complete the task those skill has to be combined, right, to complete the task. So this is one of the most important ideas in the chapter. Skill selects single skill execution. Okay, so one skill per task, no planning needed, like in a simple skill executed, not planning needed. Okay, best starting point, low latency, single skill execution. Second is parallel execution, multiple skills run independently, result combine afterward. Example, query multiple data source simultaneously, risk wasted work if too many skills runs. Okay, yeah, that makes sense. Like when based upon the task, single only skill it is executing, or there may be the multiple skill it is executing together, and the result it will combine, and it is trying to uh, detail related to it, like multiple data source, it calling and querying and getting the data, and the risk wasted work if too many skill runs. Okay, third one is uh, chain so okay, linear sequence, right? Skill A then skill B then skill C. Okay, each step depends on the previous one. Guidelines, keep chain short, error compound. Okay, and then fourth one is tree branching, like skill can fan out, agent choose between branches, can revisit unfinished branches, good for extrapolatory or multi-option task. Okay, yeah, that makes sense. Like some if the agent is going to execute certain task, but they will go in a, like a tree fashion, like a fan out, like from one it can go to the multiple 2 3 option, from next then again go to three, like tree like a structure. Okay, and then it agent need to choose the branches, okay, in which side it need to go. Okay, and can revisit the unfinished branches, so the way it is like we would do the DFS or the LFS, in the way it will go down, then it will come back whatever left, then again it will go down. Okay, yeah, that makes sense. Then the graph most expressive, arbitrary dependency result can be merged, track complex information flow, powerful but dangerous, hard for reason about, more failure nodes, design rules, start linear, add complexity only when needed. Okay, so this is the graph related, because most of the, so graph related, it is just like we can compare with the graph data structure, like the different nodes and dependencies are there. That's how it can go in any direction based upon the certain conditions and scenarios. Okay, and the fifth approach in this chapter, planning approaches. Topology define what is possible, planning how choices are made. Okay, so when they do the planning, like iterative greedy planning, choose one action, execute and repeat. Pros simple, low latency, and cons can loop or stall on the complex task. Recommended starting point. Okay, at the recommended starting point, when you will recommended starting point at the starting, this approach is fit best. And then another one, iterative greedy planning, iterative then greedy. Okay, zero shot planning, like okay, zero shot planning, agent generate a plan before acting. One example required, good for novel or multi-step task, for that is good for zero shot planning. Second, in context planning, few shot, like human design example, retry based upon the similarity, used as guidance, trade off accuracy versus flexibility. D part for this planning is plan, adaptation, react, plan, react. Okay, alternate, like region, act, decide when to continue, choose plan or stop. Best for tasks where outcomes affect next step, key strength, adaptability. The sixth chapter in this one, practical design guidelines. Okay, this chapter emphasize pragmatic choices like latency versus accuracy is a real trade-off. Count how many actions task usually need. Expect plan to fail and adapt. Test planning approaches versus the real scenario. Choose the simplest orchestration that works. Okay, so these six things are the main design guidelines for this one. Key takeaway: skill give agent power, orchestration give agent intelligence. This is the main main so two line summary of this chapter. Okay, without orchestration, two agents are a tool. With orchestration, agent become collaborator. If you want, I can do. Okay, so and this is the same things I just for I just ask that give me the cheat sheet, so it gave me the cheat sheet, like orchestration, decide, skill selection, semantic, hierarchy, the same thing that whatever we covered till now. We can skip this one. And okay, okay, I just want to go through this the code example as well. Okay, so how much time? Half an hour left. I then we can go to the actual, we can go through in the detail, but I ask for the code example as well, and then I try to understand it a little bit, like let's see, because this gave the example, but let's go to the book. Okay, so let's go. So on a high level it tell, now we can deep dive it. Okay, that's what I just wanted to do. Okay, okay. Okay. So this the part, just simply the introduction. Now we can deep dive it. We already understand summary of the chapter, okay, the summary of the chapter, and we can now just want to deep dive it, okay. So we'll see more. So skill selection, before we get into the planning, we consider the okay, before we get skill selection, okay. So first thing, like now agent, okay, so for this one, just it is editing. Now your agent has set up the skill, okay. So from here, now that your agent has a set of the skill, that in the previous chapter it was about the skills, okay. So now your agent has a set of the skill that can be used. It is a time to start using them to solve the real task, okay. With the while simple task can be handled while relying on a intrinsic information contained within the model's weight, okay. And the some task can be handled with a single skill. More complex tasks will often require multiple skill, with the potential for the dependency between these skill. Okay, so while the simple task can be handled relying on the intrinsic information content within the model's weight. So it is just like, something, you want, you ask the question or you want to do something, model is already in the model weight, means it's already trained on it. Just like you ask some question small, like what is the capital of India, or some small question, it without any tool and something, the model's weight means model already know it, it can answer it. For that you don't need any skill and something, okay. But something behind that, if you want it to be performed, then you need to depend on all these skills, and how those skills should execute, okay. Some task can be handled with a single skill, as it was saying, single skill. More complex tasks often require the multiple skills, with the potential of the dependency between these skills, right. So there should be, has to be the dependency between these skills. To handle more complex task, agent need to perform more than one action and do a reasonable order, appropriate managing dependency between the task. This chapter will cover orchestration, including skill selection, execution, skill topology, and planning. Okay. So now skill selection. Before we get
Agent
into the
need to
planning,
perform more than one
we consider the critical task of the skill selection. Okay, because it is the foundation for the more advanced planning. Different approach to skill selection offer the unique advantage and consideration. Meeting different requirement and environment, we assume a set of the skill have already been developed. So if you need a fresher, go back to chapter 3. Yeah, make sure, okay. Generative skill selection. The first selection, generative skill selection. This simple approach is generative skill selection. In this case, the skills it is a definition, it is description are provided. In this case, the skills, its definition and its description are provided, right, to a model, and the model is asked to select the most appropriate skill for a given context. Correct. You know, we can understand it very well, right. It is a
in this
definition,
skill
it is
description.
definition, the description are provided to the model, and the model is asked to select the most appropriate skill for the given context, right. For a given context, we want, okay, select this skill, then it will select, okay. Output from the foundation model is then compared to the skill set, okay, and the closest one is chosen. The output from the foundation model is compared to the skill set, and the closest one is chosen, okay. This approach is easy to implement and they require no additional training, embedding, or the skill set hierarchy to use. Okay, perfect. The main drawback is latency, as it require another foundation model call, which can add second to the overall call response. Okay, yeah, that we can understand. Like, so what it will do, it will, you provide the description and for a given context to the model, then model will tell you that which is from the which skill you need to choose, that from your given skill set. So that skill set you have it, okay. And then you select that skill, again you will ask it to execute it, right. So in that case there will be extra call. That's why I say there will little bit latency. That makes sense. The main drawback is latency. To require another foundation model call, which can add the second to the overall response time. It can also benefit from the in context learning. It can also benefit from the in context learning, where few short example can be provided to boost predictive accuracy for your problem without the challenge of the training or fine tuning a model. Yeah, that makes sense, because it can also benefit from the context learning, where the few short example can be provided to boost the predictive accuracy of your problem without challenging the training or the fine tuning a model. Yeah, perfect. And then so the method they written, okay, let's see, this code is not completely visible. From the LangChain core tool import, they record the tool, then say tool query Wolfram alpha to compute. There is a expression. So this is the doc string they gave it, okay. And then say trigger Jupyter one, and this is the another doc string, another tool, and something it is doing, okay. So this is nothing but send Slack message. This is the doc string, and it is a tool. So these are the LangChain tool, okay. These are the function only, but this is the wrapper. Actually, it is written like that, but generally it is come top of it, okay. And this is the doc string. Doc string. This is the method, okay. This is the method argument. Because of this, it will become a tool, okay. And this is the doc string for it, and it is doing something, okay. That makes sense. Okay. And when it is tried to execute it, okay. So let's see. So this is the tool they gave it till here, and this tool initial LLM GPT-4 point model. You created the temperature LLM with the tools. You give the tool human message. What is the stock prices? AI message, and then tool call in the tool chain, and it will tell it, okay. Tool name, message, something, and then final response. Okay. So what I understood out of it, like, generative selection, like, these are the way of writing the code only, that whatever we knows, okay, that you define a tool, okay. But in the LangChain framework, you take the tool, you will put a decorator on that function. That's what it is doing it. But if you see, here is nothing but actually there is no such the new code. This is the old code that what we were writing from day one. Like, you will open AI. This is the LangChain class where you will pass the model and temperature and something. You will pass. You will get the LLM object. In the LLM object, you will do those LLM object. You will call another function bind tools. Okay, there you will pass the list of the tool. Okay, that is how it is. And then your LLM tool are attached to that LLM, and then you will create a class with the human message. There you will pass the message, and those messages will be the array. Okay, you will put that into a list or array. And then what you will then on that tool, you will call a invoke function. You will pass those messages, and you will get AI messages. And those AI messages, what you will do again, this is the list of the messages are there, right? They are attaching messages to it. And then you're calling, okay, for this message, how many tool got called. So if you see AI message dot tool calls, it will give the list of the tool that got called from this call. And you get the tool call, and then it is, starting a tool call, then tool message get the stock price. Okay, then they are invoking the call and then printing the message. So and final response it came, then it is printing. So it is nothing but the way that traditionally the people write the code. So in that call only, selection is happening automatically. There is no such different design pattern for it. But I can understand it. Simbe, let me see. Yeah, correct. Tool call, stock price, and okay, fine. And then the another semantic selection. Let's go to the semantic selection. Another approach, semantic selection, use a semantic representation to identify and select the relevant skill based upon their semantic similarity to task requirement. Ahead of time, each skill definition and description is embedded using encoder only model, such as the OpenAI's ADA model, Amazon's Titan model, Current's embedded MERT model, BERT, and other model. These skills are then indexed in a lightweight vector database. Correct. At runtime, the current context is then embedded using the same embedding model. A search is performed on the database, and the top skill is selected. The skill is then parameterized with the text completion model, invoke, and response is used to compose the response for a user. This is the most common pattern and is recommended for most use cases. Is typically faster than the generative selection perform, and the reasonably scalable. Okay, so what they're saying, let's see, skill database setup. So with the Python code is this class request logging LangChain imported tool, open API for the human messages, and this is the files database it took it, okay. And import files, import numpy this one, and it create initialize the embedding, OpenAI embedding and LLM. So OpenAI embedding class is there. There you will pass the key and some other right side. We are not able to see it. Embeddings, and you pass the embedding, and then you created the embedding. So this is the embedding LLM, and then you create LLM call, then tool description, query Wolfram Alpha, use Wolfram Alpha to Jupyter, and then what it is. Okay, this is the tool description edit. Key value, okay, key value, and then key value, then key value, send message to a specific tool description. We give the tool description, create embedding for each tool description, tool embedding, tool name, and then is calling get the tool name and description from tool description. So tool description, so this will be the key, this will be the value corresponding to it, and then they are creating the embedding dot embedding test message. So whatever the description there, they are creating the embedding, okay, and then tool embedding. So tool embedding, what tool embedding is a list, okay, they are defining the tool embedding, they are adding it to it, and the tool name they are adding. So just creating the embedding, simple. Once the embedding is a initialize files vector database, so embedding tool, like just get the how many embeddings are there, then create the index. So here they are just creating the dimensions, like based upon the tool length, and that call this one created the index. Index nothing but like a collection in MongoDB, table in the SQL. Here is the index. They call the index where you will store the information. So vector database index is nothing but like a where you will store the information. Okay. Normalize embedding. As a normalize embedding for the cosine similarity. So files dot normalize. Then this passing some information, converting to list file compatible format array, and then map to a list. Then it is calling, and then it is printing, and then something is happening. Okay, so on high level, if you summarize, if you try to execute this code, then you can understand more, but I understood it pretty well. Okay, here with there above one we were passing the message, here the different message we are passing, that which tool it need to call, then creating the embedding, and then passing to the LLM, then getting the response. So whatever it was telling, this is the same approach, just to just to perform certain task. Okay, so that's what it all about, the embedding one. And now if your scenario involves a large number of the skills, however, you might need to consider hierarchical skill selection. Okay, this is typically true if many of those skills are the semantically similar, and you are looking for to improve the skill selection accuracy at the price of the higher latency and the complexity. In this pattern, you organize your skill into a group, provide a description for the each group, correct, as we saw in the summary. Your skill selection, either generative or the semantic, first select a group, then perform a secondary search only among the skill in that group. While this is the slower, would be expensive to parallelize it, reduce the complexity of the skill selection task into a two smaller chunks, and frequently result in a higher overall skill selection accuracy. Crafting and maintaining these skill group takes times and effort, so it is not recommended as a technique to begin. Okay, so again the same code is given, the request logging numpy np. Okay, so this again it is doing the embedding and defining the tool, and another tool, and another tool, and then assign tool to their respective group. Okay, so tool group like computational, and so this is the 2D vector, like computational, and you are creating different computational automation, and then another tool defining to the embedded group and task description. You to group embedding, and then calling them group embedding, create a files index. Okay, and embedded tool, and then it is trying to executing certain task and hierarchical skill selection, and then this one, this one. Okay, so this code I
Sorry, folks. This book looks old, and we have been doing this for a while now, isn't it? We did this with Gen AI book, going through these code and all of it looks so old. Um, this is a
uh,
huge waste of time.
So
uh, mhm.
what is happening here is, let's say we are using LangChain or IGNU or some other framework. they cover all these internally. This book is trying to expose that okay, oh, this is how the tool selection is happening, this is how all this happening. So if we don't want to know also, this is absolutely fine, because when you are writing an agent, it's all happens internally. Most of the stuffs it is explaining here, it's completely internal.
No, so one thing, sir, I say, okay, ma'am, you are right, okay, that because some of the concept in this one, it looks like that this one something we read some time back. Again, we trying to read something. What is that new to this one? Okay, that is true. Okay, it makes sense. I agree with your point. Okay, what from my
It,
this is my personal opinion. So whatever, if you go to the lang chain framework, okay, so this syntax wise the same syntax only, but the design pattern it is using, okay, in this book, okay, they are totally different. Seriously, I written some couple of the lot some code, okay, not some, lot of the code I will say, okay, different agent I built using this framework only, even some other framework. So there we were putting the designing a agent based upon the particular one or two example I started building it, okay. This is also using same framework, but the pattern it is using, correct, right, okay, the way, okay, those are the little different. This pattern, that whatever I reading it now, I never seen it before, okay. The way it is trying to trying to the same piece of code, but it is trying to put in a different way, okay, that if there is a problem, then how you will actually put your design pattern, okay. Most of the code, if somebody asks me, okay, how you will do it, okay, this pattern I never did it, okay. This is the same, framework not changed, coding is not changed, okay, but the approach it is using, okay, it is the new, okay, new or different for me. I am, when I'm going through this book, it is contain more theory, same way the way we were building the code, okay, the tool code, this is building in a different way, or same, it is trying to introduce different pattern when to build a agent. That's what I understand
so
out of this.
in all your lecture, and I don't know what happened in the previous ones. The main point of using introducing skill is
Mm-hmm.
not to bloat the context.
Mm-hmm.
That is the only thing that we are doing when we are using these skills. How we optimize it so that it becomes provisional, build as you go, so that the context doesn't take all of the tools and keeps the context in all the parameters of the tools. That's why we are doing all this, but in the whole lecture I did not hear anything like that.
So when you are saying the blurred the context, can you just tell something more about it? I never heard that word before.
So all this, whatever is happening is we've got a context. Let's say 100,000 tokens. Okay, that is our context. Okay,
Mm-hmm.
in which we are trying to give to the LLM that use these tools, or and then do certain task. Okay, and then you are running it for long term, and whatever it is running, whatever its chain of thought is, it is
Mm-hmm.
it is actually adding it back to the context, isn't it? That's how it knows what it is building. Okay, so now what is happening is that this context is bloating, and once the context becomes too big, the LLM loses its track. So all these skills and whatever, are putting it into embeddings, and then doing a semantic search over it and all this stuff. People came up with all this so that the context is not bloated. It is provisional. It just takes, the whatever you said, the dog string, that is the description of the tool, but it doesn't take what parameters, nothing. It doesn't. When it arrives at that point where it wants to use that tool, at that time it goes and gives the parameters. So that way the context is smaller. That is the only motto of all this chapter.
One thing I just want to little bit interfere here. Is that okay?
Yeah, yeah.
Mm-hmm.
Okay, so the thing is, as I understand, what you are talking, Shiva, context come into the picture later. The reason here is tools are only getting the data, then it will generate the context, then it will send to LLM to give the final answer. Here, let's say we are writing an agent. Let's say I have five tools. I gave the agent, these are my 5 tools, I mean these are the tools you use. So what here it is trying to say is how it will choose first which tools to execute first, whether it can be parallel, or it can be sequential, or it can be any way. So the selection 5 ways it is giving, like, okay, depending on the context or depending on what is that hierarchical, all those things. So internally it is doing the choosing which tool to be used, the sequence, all which is taken care by, I think, lang graph or something. And after execution, then it gets, okay, these are my results along with the previous context if it has saved. Along with that, it will give to LLM, okay, now give me the response. Mm, does it make sense, or
Yeah. So what you said was, it took the tool and it got a response, and now again it is collecting that, and the next time it asks, it needs to have a chain of thought, or it needs to have a history behind it. That history is the
Mhm,
context.
mhm.
Okay. And that history is every time given to the LLM. That is what it is trying to trim.
No, that is being stored in, I think in the future chapter we will see memory or something that we will store there, that context with respect to that session ID or something like that. But here what it is trying to say is how to choose tools, like tool selection and all those things. The chapter is orchestration. If it is orchestrating all the tools we have, let's say 5 tools, how we will approach that, that is what it is saying. But if we are using, let's say we are not using langgraph as a, you know, we are not using langgraph, we are writing by ourselves. This book, this chapter is explaining, if you are writing the orchestration by yourself, these are all the, algorithms available. You can utilize either hierarchical or context, or you will have your vector database, you do like this way, then it will select these tools. After that, tool execution will happen. After that, we get the all the response, that will be my context to the LLM. Then I might store that in my, memory or something, or I mean that part will come later. The intention of this, chapter is, how to orchestrate given all the tools you have. If you are not using any framework, let's say you are writing by yourself, frameworks might be using this internally, I'm sure they're using it internal. Intent is here, that's what I think it is explaining.
I mean, how many times are you going to just go and write it? We'll be using framework. I mean,
Yeah, yeah,
this
so, but
this this looks quite unnecessary.
yeah, yeah, I
I
understand your
mean,
point. If we are a developer, we may not need this because internally it's being done for us. But this chapter is trying to present, oh, if you are not using any, framework, this is how you have to do it. It is explaining
sure,
internally.
sure. Okay, I
So
understand.
so one thing, okay, okay, yeah, so the good discussion. What I understood out of it, okay, see, if you uh, developing any, let's say the microservices, or any the coding that we do, like not let's say any programming language, if you see these called the design pattern, right na? Not the system design pattern. So around 30, the gang of four, they are the list of design patterns are there if you are doing the hard coding, okay. If you see their code, okay, whatever maybe, this one, the around gang of four, how many the design pattern they introduce, right? So the over the period of time, people keep on going back and forth. That is how they develop that the list of design pattern, okay. I'm just trying to put the analogy, okay, and then try to connect that what I am trying to convey, okay. List of gang for DSIGNT. Okay. So let's say this, okay, what does it say? So if you say list gang of four pattern, okay, if you see this, okay, so these on a high level, if you know about these patterns, just try to understand. These are not the agentic pattern, but they are the uh, some of the pattern you may be knowing: abstract factory, builder, factory method, prototype, singleton, adapter, bridge, composite, decorator, proxy, lightweight. Okay, like this, there are around 32. These are the design pattern uh, related to the coding. Okay, same time, if you see the microservices design pattern, so they are the design pattern. If you follow these, somebody, if you trying to see the code of these design pattern, they look like, these are the just code only, nothing but that what we were reading in the, even in the college time, okay, that these are simple code, there is nothing, okay. But based upon the real problem, okay, how you will design your code, okay, that's where the design pattern come into the picture. So this book is trying to put those design pattern, especially this chapter, only this chapter I am talking about, it is trying to put those design pattern, okay, similar to this one only, okay. And if you sometime if you ask the, can you this, even these chapter, these design pattern are tough to remember seriously, that in this scenario how you will design, how you will write the code, in this scenario how you will design the code. So this book, you can say, it is just like those gang of four patterns only, but based upon this your scenario, it is telling you that how you need to design your the code, okay, how you need to put the code. In this book that I was telling, the way the first one, like, semantic one, I see lot of the agentic pattern code. Everybody is writing the code, in lot of the people write the code the based upon this semantic one only, that you will design the method. It is simple, that is easy to understand, that's why immediately okay, this is the method you writing a tool and doing, okay. But when it comes in a semantic one, okay, the select semantic one, I first time I see this pattern in this book only, okay. That, okay, this is another way, that the way you can, you can put the, you can design your agent, or this is nothing new, okay. In this book is not introducing any new technology, no framework, nothing, but it is telling that if this is the problem, like, it is telling then how you need to design the how you need the same piece of code, I say the agent code, you can design in a different way, okay. That's the book. About this book, I really like it, okay, that same problem we were thinking in different way, but this book is telling the same problem. If you need to your design an agent, then how you can write it. If you put this into the code, it will look nothing but it look like the normal colony, there is nothing new into it. But the way it is putting, right, okay. So the way it is putting it, it is bit different, it is more professional. So designing a one agent or something is not a big when you start, but when you will build a enterprise application, okay, the big agent ability, that's where these design pattern will matter a lot, okay. That's it will matter there a lot, like, when you are putting that, then or when you are putting it really, what will happen. Just like I was telling the problem that I was facing it, okay. I created an agent creating, so that time I follow, okay, which design pattern I need to choose, so they can just use the routing design pattern, okay, get the intent and then execute rest piece of the code. And now what is happening, because I already written 7 or 8 intent, then executing piece of the code, okay. And it is happening like that, if my agent is not able to answer all the questions, okay, that whatever asking, because then they think it is unknown intent, okay. So but if we understand this book or the pattern similar to it, you can figure out the solution of those problem, okay, in this situation or particular scenario. If you are not able to handle it, then how you need to organize the code, how you need to write the code exactly. So the way this book, the summary of this book I read, gone through it, that's what I understood it, okay. And there are the some other concepts are there, okay, we don't, we are running out of time, we can go in the depth, but we cannot go, I say. But I say, the way organizing the code, if we go more the coding example of it, then we can understand this.
तो अभी मोहन आगे क्या करना है? Should we continue this book or
ये
do
ये
something
बुक
else?
मतलब ये चैप्टर सर मैंने लिया था, तो लगभग इसके थोड़ा सा ये सर रह गया थोड़ा डिटेल में, तो चाह तो कवर कर सकता हूँ, बट आई थिंक हम नेक्स्ट सेक्टर पे जा सकते हैं। अगर कोई दूसरी बुक लेनी हो तो आप ले सकते हो, ठीक है, आप इज अप टू यू, ओके। मैंने वैसे ये
Yeah.
बुक थोड़ी हल्की हल्की अपने हिसाब से पूरी पढ़ ली है, ठीक है, कि अच्छा
Okay.
इसका क्या
What do
मतलब,
others
इसका
want?
क्योंकि
Like,
पहले ये नया कंसेप्ट
do,
रिपीट हो रहे हैं इसमें बहुत सारे, ठीक है,
mm-hmm.
कि कॉन्सेप्ट बहुत सारे रिपीट हो रहे हैं, इस टाइप का कॉन्सेप्ट इतना से पिछली बुक पढ़ी है तो ज़्यादा चीज़ें समझ में आ गई। अगर कोई ऐसी बुक हो जिसमें ज़्यादा कॉन्सेप्ट हो तो उसको भी स्विच कर सकते हैं, और नहीं तो फिर और बीच में 1-2 मिस भी हो गई, इस वजह से 2-3 वीक में हो नहीं पाया, वरना हम लोग अब तक खत्म हो गए, तो 2-3 क्लासें हुई नहीं ना अपनी वीक में, ठीक है। दैट्स व्हाई वी आर ऑन चैप्टर 5 ओनली।
So what will be valuable for everyone? Shiva, Nihar sir, what
ये
would
I
you
तो
like?
मेरे लिए वैल्यूएबल नहीं है, फ्रैंकली स्पीकिंग। आई मीन अभी तो कोई कोड खुद हाथ से लिखता भी नहीं है,
Mhm.
जो है जनरेट द कोड, सी व्हाट इट इज डूइंग, अगर नहीं है इट इज एन इटरेटिव प्रोसेस, उसको एनहांस करो।
Hmm.
और मोस्ट ऑफ द डिजाइन पैटर्न्स दे आर इनबिल्ट। जब कोड जनरेट कर रहे होते हैं तो ऐसा नहीं है कि इस तरह से याद आता है कि इस तरह से बनाना है, कोई बहुत ज्यादा एजेंट्स नहीं बना रहा है, फ्रेमवर्क यूज करना है। आई मीन ये बार बार रिपीट करने से मुझे लगता है कि इट इज वेरी रिग्रेसिव, उसमें हम कुछ लर्न नहीं कर रहे हैं नया।
Mhm.
दैट इज माय ओपिनियन।
Yeah, yeah, no, I understand you where you are coming from. Makes sense because we are using, let's say, Langs and Ignu or whatever. This is internal, completely internal. How it is being built internally. But और कोई book है क्या जो, let's say,
Yeah,
is
yeah,
there any?
Manoj, I think even
So,
knowledge and right, knowledge and memory. We also talk about again what Shiva madam is telling, right? So
Hmm.
short memory. How do we keep the memory into the uh, like learning from the previous contest? वही सिखा रहे, but I think so in case if you're talking about it, value creation means is because most of the books, what I also understand, right, the same topic is going to repeat when you talk about but as Mohan also saying, right, I think is a different techniques. That's what we're going to learn it from each book. But if you're looking for more practical practical learning, I think we have to look at different way, Manoj. I think,
Yeah,
mhm.
makes sense. Makes sense.
yeah.
But there
Yeah.
are a lot of things we can learn from here. Like, okay, so let's say it is taking that database, it is putting internally all those things, trying to select which tool. So let's say somebody has somebody is writing an agent which is complex. He wants all those things. He can do it by himself rather than relying on those things. So these design patterns things are very valuable, but depends if right now you are looking it, or in future you want to look it. For me it is okay, it is making sense. I also understand internally. Sometimes I want to know how it is really doing it. So this gives all those clarity. Even without this we can survive also, no problem.
ये व्हेन आई एग्री। मैं अपना पर्सनल ओपिनियन मेरा ये है कि ये चीज है, जैसा भी बुक चली रही थी तो
Mm.
ऑब्वियसली कि ऐसा नया बुक खरीदे तो मोस्टली भी कवर हियर द थ्योरी, राइट, कि नया कुछ ऐसा हो तो नया कुछ कंसेप्ट मिले। ज्यादातर इसमें रिपीटेड कंसेप्ट हो रहा है। मेरा पर्सनली मैं अपने हिसाब से
so another idea is well, we can actually also discuss on the group.
Mhm.
But if you want to do something new, there is a Cloud architect certification that Anthropic announced, I think, a couple of weeks ago.
Right, right.
So if there is enough interest, we can just prepare for that certification together. Cloud के कुछ courses भी हैं, like there are 12-13 courses and they'll be all up to date, latest, right?
Mhm.
So we can do maybe one course every week, like offline, and then discuss in the group, and in 2 to 3 months prepare for that exam.
दैट इज मेकिंग अ लॉट ऑफ सेंस टू मी मनोज, क्योंकि उसमें क्या है कि हम अपने पर्सनल लाइफ में क्या 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 बेटर कर रहे हैं, या आर वी यूजिंग मोर टूल्स या एजेंट्स कर पा रहे हैं क्या? दैट इज द वे टू गो। अगर हम लोग ऐसी थ्योरी पढ़ते रहे तो पढ़ते ही रह जाएंगे।
हम्म
Yeah,
मतलब
Manoj,
मेरे
I
को
think
पता नहीं कि इसमें कितना प्रैक्टिकल है, बट इट्स गोइंग टू बी लेटेस्ट, यार हरिराम।
yeah. Oh, ऐसा भी कर सकता है क्योंकि I think see, and that's also best idea. I think by that I think we can also individual also will have interest to get their certificates, right? And that means some adding प्रोफाइल का थोड़ा ये हो जाएगा।
ओके।
एग्री में, इवन मैं भी एग्री हूँ। तो मैम जो बोल रही हैं वो ठीक ही है। ये बुक अब मतलब जा रहे हैं, लेकिन तब काफी कंसेप्ट इस टाइप के कवर हो गए, अब बोरिंग सी लगने लगी है कि अब ज्यादा सेल्फ लर्निंग भी हो सकती है। ये मतलब कि जैसे चल रही तो इसी में ऐसा कुछ डिसीजन नहीं होता। लास्ट टाइम भी ज्यादा लोग नहीं थे, अब मनोज सर भी नहीं थे शायद लास्ट टाइम। तो ये डिसाइड नहीं हुआ कि क्योंकि हम बुक पढ़ते हैं एक बार फिर वो रिपीट होने लगती है कुछ हाफ के बाद। तो बेटर है कि हम ऐसे पैसे भी करते हैं, दैट इज गुड। लाइक कि बाकी कंसेप्ट अगर सेल्फ लर्निंग करो, मैं तो लगभग खत्म ही कर चुका हूँ उस बुक का आधा। बाकी थोड़ा बहुत देखूंगा तो हो गया। बाकी पर्सनली अपने इंटरेस्ट पे जा सकते हैं, अदरवाइज वी कैन स्टॉप हियर ओनली। बट द मेन कंसेप्ट थे उसके, वो काफी हद तक हम लोग सीख गए हैं, ठीक है। और अब कोई ऐसा नया पकड़ते हैं जिसमें एक लोग टोटली नया हो और कुछ है, जैसे आप सर्टिफिकेट का बोले, इज रियली गुड, ओके। तो आप एक बार ले लो, फ्रॉम माई साइड इज गो। कुछ नया सा लग रहा है, नया कंसेप्ट सीखेंगे कुछ है, तो उसको कंटिन्यू करते हैं सर।
ठीक है, तो आई शेयर द लिंक ऑन व्हाट्सएप ग्रुप, जस्ट गो टेक ए लुक एट इट। And if it still seems exciting to everyone, just put a thumbs up, and then maybe we'll create a plan, learning plan of some sort.
हाँ ठीक है, good,
Okay.
that sounds good.
Good.
Okay, is
Thank
it
you.
completely to Claude or it's generic basically? Oh, well,
ये
I
तो
don't know actually.
ये तो क्लॉड रिलेटेड ही है, लेकिन अभी जो मेरा जो एक्सपीरियंस है, प्रिटी मच ऑल ऑफ दीज बिग फ्रंटियर मॉडल्स और एजेंट्स, दे आर एट द सेम लेवल. आप एक का पढ़ेंगे तो ट्रांसफरेबल नॉलेज है.
राइट, करेक्ट, एग्री. एक को पढ़ लो ना, बाकी सब तो अपने आप सीख जाओगे. फिर आपको आपको इम्प्लीमेंट करना है तो आप डेप्थ में चले जाओ. ठीक है,
हाँ,
जस्ट लाइक आई एम
हर एक
गोइंग,
का
ओके, आई एम गोइंग.
नहीं पढ़ा जा सकता है कि
हाँ, तो नॉट
ये
एवरीबॉडी इज गोइंग, आपकी इंटरेस्ट पे आप जा सकते हो, तो ऐसा कुछ नहीं है. तो
Hmm.
दैट्स एग्री, एक का हो गया, बाकी
Okay.
सब सही है.
Okay. Cool. Or we can also think of meanwhile ये में ग्रुप में डालते हैं, और these are new things coming. अगर हम लोग को देखना है तो we can also think other alternatives meanwhile.
अगर किसी के पास कुछ और आइडिया हो तो दे आर कैन आई
Mhm.
शेयर. आई डोंट हैव एनीथिंग टू शेयर द न्यू थिंग, बट आई एग्री द
Okay.
सर व्हाट आर द
Okay. Cool.
proposal.
Yeah, but Manoj, I think somehow we need to continue also because it's very good because at least some learning हो जाता है.
Yeah, it's very
Yeah.
good and very exciting also.
करेक्ट, एग्री.
चलिए, ठीक है. I'll explore that exam and I'll try to find some resources. I'll share on the group.
Yep. Thank you.
Sure.
Sure.
Okay, thank you.
Thank you,
Chalo.
everyone.
Appreciate
Bye.
it. Thank you.
Yeah, Mohan. Thanks.
Bye.
Thank you.